Hello, good morning. This is Nas from NB Network Lessons. Hope everyone's doing okay and in high spirits. Hello from steamy Dallas, Texas. It's a hot day in Dallas today. So if you live in Dallas or I would say anywhere in Texas, drink lots of water, stay indoor if possible. But anyways, date today is 8/16/24 and this is physics lesson number 21, and we're going to discuss and show you that acceleration is a slope of velocity in a graphical manner. But before I do that, I just would like to let a lot of people, a lot of calculus students or physics students get afraid or get scared when they hear the word derivative. Don't be afraid. Derivative is nothing but rate of change, slope, rise over run. Okay. So anytime when something is changing, you measure the rate of the change. That's basically your derivative. Okay. So, and I'll show you that in a graphical form. I think that will make much sense to you. You can probably send me a message in the comment and let me know if that made sense to you. All right, so let's go ahead and draw a position or a distance graph. Let's say we have on y-axis, we show distance, and on x-axis, we have time in seconds, okay? And over here, I'm gonna show position. In old books, they showed this as d, showing distance, especially in British model of physics. But let's say this is in meters, okay? So let's go ahead and put some tick marks up here. 1, 2, 3. Let's go ahead and on the y-axis put 1, 2, 3. Okay. Now what we do is that we draw a graph right here, and then I'm gonna have draw this with the ruler, something like this. Okay. So now what we have is that this is a straight line, right? Everybody agrees this is a straight line. So basically, what I'm saying is that at 1 second, I have covered distance of 1 meter. Agreed? At 2 seconds, I have covered the distance of 2 meters. All right. At 3 seconds, I have covered the distance of 3 meters. Right? Right here. Now, what I'm saying is that if you take the derivative or a slope of this, that will give you velocity in meters per second. Let's see how. So slope, which is essentially derivative, is rise over run. Okay. So then when I'm taking slope, I'm saying I'm finding velocity. So let's say, let's mark these points at A, B, C, right? So I'm saying, what is my velocity at point A? In other words, what I'm asking you is, what is my derivative at A, or what is my slope at A? So then I would say at point A, rise is 1, run is 1, so my slope is 1. Point B, so this is 1 meters per second velocity because I took derivative of distance. In other words, what I'm saying is that in 1 second, I have covered 1 meter. Let's say at point B, rise is 2, run is 2. So I have covered 1 meter per second. So in other words, from here to here, I've covered 1 meter, 1 meter. My speed is 1 meter per second. From here to here, also my speed is 1 meter per second. And if you do it at point C, it would be basically 3 over 3. That is also 1 meter per second. So did you notice anything? That the slope is constant. There is no rate of change. Okay. At every point, my slope is 1. Okay, so keep that in mind, that derivative of a straight line, you get velocity. Now we're going to look at derivative of velocity, and we're going to get acceleration. So on the graph, I have this curve. Okay, this is my velocity in meters per second. This is my time per second. I'm not going to put any numbers on it, but I think once I draw it, you will get an idea. So let's say we have this as point A, okay? And let's say this is point B. Let's say this right here is point C. And let's say this right here is point D. So now this right here curve basically is my velocity curve. In other words, what I'm saying is that at this point, I have basically my velocity or my speed is this. At this point, my velocity or speed is this. And then I get to the top, and then my velocity starts decreasing, right? So what we need to do is we need to find derivative at these points to find the acceleration. I'm not giving any numbers or anything, but I'm just going to show you general concept. So let's say in order to find slope, what we do is that we draw a tangent line which barely kisses this point A. Okay, so I'm going to do that. I'm going to try my best to do it. So let's say this right here is tangent. Okay, and then this right here is a tangent. Okay, it's barely touching point B. All right, do this again. This right here, okay, is a tangent to point C, and then this right here is tangent to point D. Now let's analyze these. Okay, now let's analyze these. What the heck am I talking about? Okay, so at point A, what do you think my slope is? Is it going to be positive or negative? By just looking at this, this right here, my slope is positive. Okay, this is positive slope, right? This is positive slope, and you have something like this. This right here is negative slope. Okay, so my slope is positive, therefore my acceleration derivative is going to be positive. Okay, so at point A, we have positive slope and positive acceleration. I'm just going to put A for acceleration. Okay, at point B, that's a good question. What would be my slope at point B? We just went through this, rise over run. There is no rise and run over here. It's just a freaking straight line, right? So then what would be my slope? Slope would be a constant. So when you have a constant slope, okay, so when you have constant slope, my acceleration would be 0. In this case, my acceleration was positive. But since there is no rate of change, nothing's changes, rise over run is basically a constant. So that's why acceleration is 0. In this case, acceleration is positive. Now, what about in case of C? What do you think my acceleration is? This slope is negative, right? This slope is negative. So we have negative slope. If you have negative slope, then your acceleration is going to be negative. Okay? What does that mean? That means you're slowing down, right? That you are slowing down. Now, let me ask you this. What about at D? D also my slope is negative, okay, minus slope. So the acceleration at this point is going to be negative, okay. Now let me ask you this. This is a bonus question. Based on this graph, you think we are slowing down more at point C or at point D? That's a question for you. So obviously we're going up, we're gaining speed up till we get to the point B, then we stay constant for a little bit, and then we de-accelerating. Our acceleration drops at point C and acceleration drops at point D. Question is it dropping more at point C or point D? Point C, okay? Because just look at the steepness of this line right here, okay? So yes, the bonus question is, at which point, and this is a test question by the way, at which point the acceleration drop is fast, at point C or point D? Point C is the answer. Now, one last question before one last discussion before I close this. If you have this straight line right here, if this is more steeper, if this line is more steeper, say towards the y-axis, that means I'm going fast, because in less distance I'm covering more, in sorry less time I'm covering more distance. Would you not agree? Let's say if I move my graph like this right here, my time is 1 second or maybe 1.5 seconds, I've covered 3 meters. If this graph is more towards x-axis, okay, that means I'm going slow. I've got an older model of car and I'm going slow. And it makes sense because distance, let's say, is 1.5 meter and you're right here. So that means in 3 seconds, you've covered only 1.5 meters. So these are the concepts which you need to grasp, and we'll move forward with more topics. Follow me up on the next lesson and we'll discuss uniform motion. Thank you so much for watching. If you like the contents, please go ahead and give me a like. Take care of yourself and share the knowledge. Thank you.